Hello, this is part 2 of a 3-part video series on addressing beamforming test challenges. This video describes the key measurements to visualize and validate your beamforming applications. Be sure to watch part 1 on the application and measurement challenges, and part 3 on showing how the Keysight multi-channel Lte-A Lte Advanced reference solution combines the multiple phase coherent PXI vector signal generators and the PXI vector signal analyzers with the Keysight industry-leading application software and multi-channel configuration and correction tools to allow you to accelerate your test setup and gain deeper insight faster. Our application expert, Craig Grimley, will now walk through some key beamforming measurements.
With the 89600 VSA software plus multi-channel signal analyzer, we can start by viewing the time-synchronized RF signal capture from all 8 antenna elements. Enabling the 89600 VSA spectrogram feature, we can immediately gain insight into the frequency resource activity. This allows us to quickly build up a picture of per subframe RF activity levels for user-specific resource block scheduling as well as common control channels and signals. Note this feature does not require any demodulation at this point and is a very useful debugging tool when investigating unexpected RF or scheduling issues, especially when those issues impair normal demodulation of the signal. Prior to demodulating the TD-LTE captured signal, we need to configure the 89600 VSA software antenna group parameter with the appropriate number of elements and spacing used to match our physical RF antenna configuration. As mentioned earlier, the beamforming weightings can be changing on an individual resource block basis. Therefore, we may choose to view the UE-specific weighting results on a per resource block basis or, alternatively, per user allocation. The TD-LTE measurement application provides a rich set of demodulation results to help you verify and visualize your MIMO beamforming signals. Available results include IQ constellations, EVM result metrics, detected resource allocations, UE-specific reference signal weights, cell-specific reference signal weights and impairments, and UE-specific and common broadcast antenna beam patterns. Let's take a closer look at some of these result traces. The demodulated IQ constellations are displayed per spatial multiplexing layer and provide a quick visual indication of the signal's modulation quality correctness. The frame summary trace provides access to individual EVM and power metrics associated with each channel and signal type. It also provides a color key for all channel type results, which is reused throughout the VSA traces. The detected allocations trace lets you visualize the resource block allocations for each user-specific transmission, plus resource allocations used by common control channels. Measured UE-specific reference signal weights are presented in table format for each of the 8 antenna elements. Weightings can be evaluated in both magnitude and phase down to the individual resource block allocations associated with each user transmission. Separate UE-specific reference signal weights traces are available for each spatial multiplexing layer. To help you visualize the beamforming performance, the VSA software also presents the resultant combined beam pattern trace associated with each antenna group. Measured UE-specific reference signal weights from the first 4 input channels are used to compute the antenna group 0 beam pattern trace. This process is repeated for the second 4 input channels to compute the resultant antenna group 1 beam pattern trace. Note that a separate beam pattern trace can be visualized for each resource block associated with each user device. Similar to how the IQ constellation provides a quick visual health check of modulation quality, the antenna group beam pattern trace provides a quick visual health check of beamforming baseband encoding and RF calibration quality. Any identified anomalies can be investigated in detail using the UE-specific weight trace metrics. Channel frequency, magnitude and phase response traces can be viewed simultaneously for all 8 antenna elements, along with the VSA-supported common tracking error trace. The VSA MIMO InfoTrace reports cell-specific reference signal metrics and impairments measured for all 8 antenna elements. Reported metrics include cell RS power, EVM, timing, phase, symbol clock, and frequency error, allowing you to verify the common broadcast beam pattern weightings associated with each antenna element. The VSA software also extracts these relative antenna weightings in order to produce the cell RS-derived sector-wide broadcast beam pattern, shown here in blue. The user-specific and common broadcast beam pattern trace results can be viewed in either IQ polar format or alternatively in log magnitude dB format. Both formats support VSA markers for easy tracking of main lobe peak levels and azimuth locations during live measurement updates. VSA markers can also be used to read out various beam pattern characteristics like null depth, azimuth locations, and main lobe to side lobe levels. A key metric to be verified within TD-Lte beamforming transmissions is beamforming gain. The VSA software has added a new beamforming gain results trace specifically for this purpose. It reports the dB difference between each UE-specific beam pattern and the common cell-specific broadcast beam pattern to produce a beamforming gain trace result for each user allocation. The beamforming gain results can be viewed for each individual resource block associated with each user's allocation.
Thanks, Craig, for the detailed explanation on these measurements. Be sure to watch the next video in this series to find out how the Keysight Lte-A Lte Advanced multi-channel reference solution provides the essential elements of the solution that enables you to get to results quickly and with more confidence. Thanks for watching. For more information, be sure to visit us on the web.